Okay, colored pens. Now we've been studying linear systems for about 2 weeks or so. So let's see how we're doing. What was the system that you wrote to represent the scenario in the question? Give me one of your equations. Give me one of them. Tristan. Okay. Give me a thumbs up if you also have that same equation in your system. Of course, to know that you would have been listening very carefully. Okay, Kayla, you had that exact same one? What was your other equation? Okay, so everyone give me a thumbs up if you had that in yours. Okay, some of us, a lot of us it looks like. Good, put your thumbs down. That was the system that we were looking for. Right there. Number 2, solve the system. What do you get? 3 confident people, 5 confident people, 6 confident people. We'll start with Brandon, Zabari, and then Alyssa. What'd you get? Okay. Okay. Okay, so we have slight disagreement. The answer is infinite solutions. But Brandon, what did you say your answer was? 0 equals 0. So that's not a solution because a solution to a system is an ordered pair. But then there's 2 special cases where you could have infinite solutions or no solution. What you told us is important though. You have given us the support that proves that answer. When you get a valid equation but no variable at the end, that means infinite solution. So you have to be able to look at this and interpret what it means. It means that you have 2 lines lying on top of each other. Infinite solutions. So now number 3, the question is, with the information we have, can we find the price of the specials? It's a simple yes or no question, but you have to be able to explain it. So we got a couple people who think they can give me a yes or no answer. Okay, Catalina, what did you think? No. Brian, what did you think? No? Okay, Catalina, how come? Okay, good. Brian, what did you say as far as why?
Since in the 2 special cases, no solution and no solution, we don't have one solution, you can't be.
Okay, very good. I like what you just said. You need something more. So here's the weird thing, and they're both right. The answer was no. Here's the weird thing. The vegetarian special has a price, and the chicken special has a price. We can't find it with the information we're given. The information we're given is basically 2 different versions of the exact same thing, and so we are unable to find the information we need. We would need to be given other information to then find the costs. Okay? Comments, questions? Okay, one last thing I want to look at. Back to number 1. I would like to know how you solved the system. How did you solve it? What method did you use? Alicia, what method? Good. Elimination. And how did you set it up to eliminate?
I divided the bottom equation by -3 and the top by 4.
Wow, that was absolutely brilliant. You divided the bottom one by -3, you said? Divided by -3, and then you divided the top one by 4. And what goal were you trying to accomplish by doing that?
Because the x x and the y being both multiples of the 4, and for the bottom and the 3.
Okay. So you were trying to achieve what?
For them to be opposites and because 21 and 28 are
Yeah, there you go. That was the word I was looking for. You were trying to achieve opposites right there, or it turns out right there. And by doing this and doing that, you did a very creative and very advanced way of doing that. And so you end up with 7x and negative 7x, which were the opposites that you wanted. But then what else happened when you did that? That's right. So this ended up with opposites, and in fact, this ended up with opposites, and everything canceled each other out. That was brilliant. Brilliant approach. That was certainly not the only approach. What other things could you have done to set it up for elimination? Sebastian? You divided the top by negative 3 over 4? Divided by negative 3, so you multiplied by 4 over 3. You multiplied by 3 over 4. Okay, and so you just multiplied the top one, and that got you the opposites that you wanted? Very good. Very creative approach. I like that. Come on. Yeah, and that's what I did the first time I did it, is I multiplied the top one by 21, the bottom one by negative 28, and that definitely gets your opposites. The difference between the approaches is really a matter of convenience. Multiplying by 28 and 21 will generate very big numbers, especially when you multiply times that and that. Using Alicia's approach, here and here, will give you very small numbers, and that just makes it a little bit easier. Neither is really better or worse, but it does make the math a little bit easier to deal with. Okay? Very good. So we had, what, 3 or 4 different approaches already, and there was another approach over here. What did you do? You multiplied by...
44
Right, so you did the same thing that Kamoy did, except you did it to those. So that was yet another approach. Very good. So we have a lot of different possibilities, and that's being creative. Okay? Comments or questions on anything from today's warm-up? No, this is something new I'm doing when there's a question that has a lot of text or a lot of information, and that would take you a long time to copy down. I am, from now on, going to try and give you a little printed version of it, so it save us time, okay? All right. We've spent the last 2 weeks studying systems of equations. Systems of equations. We're actually done studying that for now. However, we're going to move to a topic that's very related and a bit more complex. Systems of inequalities. So, before I get into some of the ins and outs of actually working with systems of inequalities, I want to do a little bit of review. So I'm going to use a different computer program, and I'm hoping that I will be able to use the board and the pen. I may have to go down and work with it directly on my computer. So everyone put your pencil down, and I need you focused up here. So up here you see the graph of a line. So now I am rewinding way back to chapter 4. We started out, after we got some basic understanding of algebra, we started graphing lines. Okay? So here's an example. In chapter 7, at the beginning, I introduced the idea of a system and graphing a system. And so what we learned was that we were introducing 2 lines on one graph. And what were we looking for once we introduced that second line? What was it that we started looking for? Yes, guy? The intersection. Brandon, what's another name for the intersection? The solution. And so what we figured out was that the solution was right there where the 2 lines cross. Let me back up again. What's a solution for this line? Zavar? Could not have said that any better. So Kusara, what he said was just critical. Every point on that line is a solution to the equation. That's what a line is. It represents all the solutions. So everywhere on this line is a solution. Let me take this one away, if I can, and put this one. Every point on this line is a solution to this equation. It wasn't until we introduced both of them at the same time that we then learned that this system now has one point that represents the solution, and it's the point of intersection, right there. Any questions about that? So this is stuff you already know. Let me back up again. At some point, we started working with inequalities. And we didn't just graph the line, there was something else we had to do with inequalities that was new for us. What did we have to do with the inequality to represent the solutions? Nisa? Bless you. We have the shade. Because this is an inequality, it has many more solutions than just the line. It actually has an entire region of solutions. And so, since this is y is less than, we shade that whole area. And now every point in this shaded area is a solution to this. That's what you learned in chapter 6. Does anyone have any questions about that? So now, think of the next logical step. I'm going to back up again. We went from one line to two lines. Looked for the point of intersection. Now, we have one shaded region. What do you think is going to happen today? Catalina? Yep, you're saying it right. Go ahead. Gather your thoughts. You said that perfectly. I'm actually amazed that the first person I called on figured it out already. So here's what we're going to work with today, is now I'm going to introduce the second inequality and the shaded region of that. And what do you notice that has happened? Ania? Okay, gather your thoughts, and then I'll call back on you, and then you try to relay your thoughts. Come on. Where is it shaded purple?
At the bottom where it goes across.
Okay, and that's what Catalina was referring to. She had never even seen this before. Or maybe she read ahead, which is I asked you to. But so this area was shaded a blue. This area, it's hard to tell, is supposed to be shaded kind of a reddish purplish. And then all of a sudden, this area down here, they're both shaded. Go ahead, Alyssa.
Those are the solutions.
That's right. So that's a major connection, is that this region here represents the solutions to both of these. This region over here is a solution just to the blue one. This region over here is just a solution to the red one. The purple section is the solutions to both of them. And so today you're going to actually learn how to do what I just demonstrated. Comments, questions, concerns? Good. Before we start actually doing it, we need to improve one of our skills. So, I want you to look at this and do not copy anything. And let me actually just put up the first few. And I'm giving you a printed version of this because it's just too much to copy. And so, again, don't do it yet, but leave some space on your paper and you'll staple it in a few minutes. Okay? And that way, it's basically part of your notes. I'm just doing the work for you. But I need you to look at this, and the goal is to figure out a shortcut for figuring out which side to shade. Because, you're welcome, because we had to do some work to figure out where to shade, and I'm going to review that right now. So, if everyone will look at the first grid, this right here, y is greater than negative x minus 8. That's the graph of that. We learned how to do that in chapter 6. But when we had to figure out where to shade, this is what we did. We took the point 0, 0, because this is what I told you to do. I said, let's take the point 0, comma 0, and we're going to plug it in for x and y. And if it's a true statement, that means that 0, 0 is a solution. If it's a false statement, that means 0, 0 is not a solution. And that will tell us which side to shade. And so in this case right here, 0, 0 is a solution. And since it's a solution, we shaded this side. So we had to do that work. But now we're going to be doing a lot more shading, and we're going to be doing a lot more inequalities. We would like a shortcut to help ourselves, and I'm bringing it up because there is a shortcut. I actually had encouraged you in chapter 6 to see if you could figure it out. A few people did, and some of us did not. Today, my hope is that everyone will be able to understand it. So what I want you to do is I want you to look through all 3 of these top ones. And let me get rid of my markings so far. I would like you to look at the symbol that's here and which side is shaded. This symbol here and which side is shaded. And this symbol here and which side is shaded. And I would like you to see if you can come up with a conclusion as to what's going on here. Is there some connection that we can make between all these? So there's a few people who have thoughts already. Give me a thumbs up when you think you see it. 4 or 5 people who think they see it. Don't put your thumb up if you don't see it. It's not supposed to be like a gotcha moment. I'm just curious. Okay, so we're going to help some other people we're going to help you get pushed along. So Alyssa, what do you notice?
In the less than side is shaded below, and in the greater than side is shaded above.
Okay. Okay. Sebastian, what did you notice?
The
Same
same thing.
thing? Okay. So that's pretty much what we're talking about, is that this says the y's must be greater than this expression. And so we shade above this line. This line is dividing the grid into 2 sections. But we need the greater than, and greater means above. Likewise, this one here says y's are less than. So we shade below the line because less than means below. And so that is pretty much the shortcut that we're going to use to save ourselves a lot of time and effort. And you can see this pattern continues, but then it changes. Look at the ones with just the x. Now all of a sudden it's a little bit different because there is no y. So now it's a little bit different, but it's the same idea. The line here is dividing it into the left and the right instead of an up or down. So now you just have to look at the symbol and you can clearly see that the x's need to be less than, so we're going to shade to the left. And here the x's need to be greater than, and greater than is going to be to the right. So logically it makes perfect sense. That trend continues when you get rid of the x's and you just have y equals or y is greater than. Like here, here, and here. Y must be greater than -3. Here's -3, so we're going to shade above. Y is less than 9, so we're going to shade below. Any questions or comments on this shortcut that we can use for shading? Good. So we're going to jump in and do one. So start by writing down the system for example 1. Now, for the shortcut to work, there was something that all of the inequalities that I gave you, something they all had in common. What do they all have in common? There's a few things, but there's something in particular that they all have in common. Jada? Yeah, what is that called? Okay, well you caught on to the important idea, so that's the most important thing. Kayla, what's that called? Yeah, they're all in slope-intercept form. The shortcut doesn't really work unless we get the inequalities into slope-intercept form. So even though we could graph these two using intercepts, we're going to use the method of slope-intercept form. But we are getting incredibly good at doing this. So we're going to actually do a lot of mental math. I hope you can follow along with this because I'm going to do the 2 steps mentally. Hopefully you can follow along. So to get this into slope-intercept form, we have to subtract 4x from both sides. And so I know in my head that that's going to be a negative 4x over here. And it's going to disappear from here. Then I also know that I'm going to divide everything by 2. So I can do all of that mentally, and I'm going to end up with y is greater than or equal to. And so I had a negative 4x here, but then I divided it by 2, so now I've got a negative 2x. And then I had a negative 6 over here, but then I divided it by 2, so I'm going to have a negative 3. So I hope you were able to follow along. I was trying to model what was going on in my head as I was doing that transformation. We need the second one as well. That's a little bit easier. Subtract 8x from both sides and we get y is less than negative 8x. Does anyone have any questions on what we've done so far? Sebastian?
Is the rule where if you divide by a negative number,
Yes, it does. Yes, it does. Very important. And I'm glad you mentioned that because there was one thing I had meant to say earlier and I didn't, is that everything about my class is details. I've talked to you about that before. That is magnified by about 1,000 during this lesson. There are so many minute details in working with systems of inequalities. One little detail wrong is going to mess you up. And that is very tragic and it's unfortunate, but that's the reality. So I'm just trying to get that reality out there so that we can just deal with it up front. Okay? So, now we need to graph both of these. So, we're experts at this. Let's graph the first one. We have to pay attention to the type of line that we draw because there's 2 different types of lines when we have an inequality. What type of line do I use for that symbol? What type of line do I use for that? Eric, do you remember what type of line? Dotted? What were you going to say, Catalina? Solid? Okay. Well, you said the right word, solid, but he disagrees. He thinks it's dotted. So how can we be sure which one it's supposed to be? Ania? Look at the what? Okay, but you don't need to because there's a clue here that tells us whether it's solid or dotted. Zabari? Yeah, if there's this line underneath the symbol, then it's a solid line. If there's no line, then it's a dotted line. So the first inequality is going to be a solid line. So here we go. We're going to graph. So we start at negative 3. That's our y-intercept right here. And now our slope is negative 2 over 1. So I can go down 2 over 1, or I can go up 2 to the left 1. Either way is fine. And now I'm going to draw a solid line through them. Make sure that you draw your line completely through your grid. Now we need to shade. And now we're going to use our little shortcut to shade. Which way should I shade? It's a little hard to tell when it's a slanted line, but we're basically going to be doing above or below. So this symbol right here tells us to do which direction. Should I shade above or below? Got 7 people who have an idea? 9 people? 10 people? Kimoi, what did you think? Above. Anissa, what did you think? Yeah, we're going to shade above. Above, in this case, is over here. So, now listen carefully. You are going to use your pencil like an artist uses a pencil. You're going to shade lightly. You've already seen, using a computer program, what's supposed to happen. We need to be able to see the overlap of 2 shaded areas. I am using a powerful computer with different colors. You don't really have that at your disposal, so you need to shade like an artist. If you hold it like you're writing and you draw a dark area, it's not going to work very well. You want to shade lightly to start with. So all I've done so far, all we've done so far, is we've graphed that right there. We learned how to do that, one inequality, during chapter 6. Now, the new part is we're going to put the second inequality on the same grid. Does anyone have any questions so far? So now we need to graph y is less than negative 8x. The y-intercept is 0, 0 right here. And now we need to either go down 8 over 1 or up 8 to the left 1. 1, 2, 3, 4, 5, 6, 7, 8 to the left 1. We're down 1, 2, 3, 4, 5, 6, 7, 8. Right there. What type of line am I going to draw for this one? What type of line do I want for that one? Tristan? The dotted line. So when you're using your ruler and your pencil, just you put your pencil down along the edge of the ruler, slide it a little bit, then lift it up, and then slide it a little bit and lift it up, and just kind of keep repeating that process, and you'll have a dotted line. Again, I'm lucky I get to use a powerful computer to help me. I'm going to have to try again. I wasn't really close enough. All right, well, I was a little bit off, but it's a little bit hard to get it exact. So I've got my dotted line. So now which way am I going to shade for the dotted line? Am I going to shade below or above? And in this case, what does below and above mean? Because the line looks like it's almost vertical. So it's bizarre, because above and below seems a little strange. Which way do you think? Hezekiah? Okay, we'll use words that can tell everyone which way to go. To the right side. So we're going to shade over here. What's that? Okay, Alicia, what did you think? To the left? Okay, so right away we have a disagreement. So you think over here and he thinks over here. What did you think? Shelby, which way do you think we should shade? To the left. Stephanie, which way did you think? To the left. Yeah, this symbol is saying less than, and it's a little hard to tell because the line is almost vertical, but it is slanted this way. And so below the line is going to be over here. And above the line is going to be over here. We need to shade below the line, so we are going to shade this area right here. You are going to shade lightly again. But when you finish shading, something emerges. And you saw it during my demonstration at the beginning. It's a little bit harder to tell with just pencil. And if when you go home and you want to do your homework, if you want to use colored pencils and you shade lightly, it might help. But unfortunately, not everyone has that at their disposal. But what emerged in mine, if you use mine as your guide, what emerged? What popped up as I finished shading? Got 5 people who have an observation, 6 people. Catalina and Ania, what did you notice?
Which the both are like shaded.
Okay, Ania, what did you notice? We'll say it your way. Not okay, I'll come back to you in a moment. Anissa was going to also share. Go ahead. What did you notice? Okay, you said that beautifully because you're the first person to mention that a different color popped up. I didn't use green. I used yellow and blue. So I actually understand how color works as well. And I knew that when they overlapped, that they would form green, which I learned in kindergarten. And now I'm employing that idea here. So Anissa's bringing up that all of a sudden this green area popped up, and then she went a step further and said, that's the solution area. This represents all the solutions that will work for this system. And so in actuality, we don't want any of this, and we don't want any of this. What we want, and now you're going to use your pencil darker, is we want to now darken in this area so that it is very clear what the solution area is. This is the solution area right here. All inside there is the solution area. I don't know. That's a good observation. Did it do that here? It did. Okay. Let's see what happens next. And then you see if you want to refine your thought. It's a good observation. Brandon and then Catalina. Let's wait and see what happens in the next few examples, okay? Sure.
It's like x is less than or equal to -5, and then you shade the opposite to square.
Okay. So let's wait and see if your thought is supported by other evidence. Okay, Shelby? I'm sorry? Okay, I'm sorry. We got a little distracted. Sorry, say it one more time. Okay, so now we're going to explore Shelby's idea. So now watch carefully. Now I'm going to introduce yet another color. Hopefully it's bright enough that it will pop out. So now everyone put your pencils down and look up here. And now I'm going to pick some points and you tell me what they represent. So what if I pick that point right there, took the coordinates, and plugged it in? What will happen? Eric. What about the second one? Okay, so Eric thinks that if I plug these coordinates in here, it will work for the first one but not the second one. Give me a thumbs up if you agree with his thought. A lot of us agree. Okay, let's maybe put your thumbs down. What about if I pick this point right there and I plug it into the system? What will happen? What do you think will happen? What do you think, Kamoy? The second inequality?
No.
But not the first one? Okay. Give me a thumbs up if you agree with Kamoy's statement. Yeah, both people were right. Put your thumbs down. So now the question is, and it's a little hard to see the grid now, but what if I pick that point right there and I plug it into the system? What will happen? Brian? Good, I like the way he said that. It'll work for the entire system. So basically, it's a solution to the system. These points are not solutions to the system. They'll work in one, but not the other. This is a solution to the system. So now Shelby pointed out something else. Shelby, you pointed out what? Very good. There's this white space over here. So let me pick a point in there. What if I pick that point right there and plug it in? What will happen? What do you think, Ania? What were you going to say, Alyssa?
It's not a solution to
Yeah, it's not going to work in either of them. Very, very important. Very good. Okay? And that was great that you brought that up, Shelby. So I feel comfortable, and based on your survey results, you guys are definitely getting a good, deep understanding of what is happening here. Okay? Does anyone have any questions about the process or interpreting or anything at all? Eric, you had a comment or question? It doesn't matter. Go ahead.
You know the sheet part, right?
Mm-hmm.
I think it's somehow related to linear systems, because in the shaded part it could be infinite solutions and solutions for shaded part for one of the equations could be only one solution, and the white part, one shaded, could be no solutions.
Okay. Interesting thought. Let's see what you think after we see a few more. Okay? Brandon?
What if the inequalities are almost the same except for the signs? So like one has it shaded on that side and one has it on that side. That kind of
Why don't you wait, see a few more examples, and see what you think then, okay? Good. We're doing well so far. So now, I'm going to introduce something that you've never seen before. A system with three. Now, it's not equations, they're inequalities, but now there's three inequalities. So, we're going to graph this system. Now again, to refresh your memory, we're using the method for graphing of putting things in slope-intercept form because that also helps us with a shortcut for the shading. So we could use another method if we wanted to, but to get the shortcut to work well, we want it in slope-intercept form. Again, you should be a Jedi master of doing this at this point. So we're going to go very quickly, and I'll talk you through my mental process. You should have either a similar mental process, or yours might be quite a bit faster than mine, because as I've said repeatedly, you guys are much brighter than I am. So we're going to convert this inequality to slope-intercept form. We have to add 2x to both sides, so that's going to jump over there. And then we're going to divide by 5 for everything. So it's going to end up, excuse me, it's going to end up y is less than, and I know it's going to be 2 over here, but then I'm going to divide by 5, so it's going to be 2/5 x, and then there's a 5 here, and then I'm going to divide it by 5, so that's going to be a 1. I need the second one. So I'm going to subtract this x, and so it's going to jump over here and become a negative x. And then I divide everything by 2. So it's going to be a negative 1 over here, negative 1 over 2. So I got y is less than negative 1/2 x. And then it's going to be 3 divided by 2. So I could put 3/2, but since that's a y-intercept, I'm going to write it in a way that makes more sense to me. 1.5 makes more sense to me for a y-intercept. And then the last one is already in the simplest form. X is less than 4. Any questions on how we did that? So now let's graph all of them and do the shading one at a time to see what emerges. So the first one, the y-intercept is 1. Rise 2 over 5. 1, 2, 3, 4, 5. Rise 2 over 5. What type of line am I going to use for this first one? Dotted or solid? Sebastian? Dotted. Got to make sure that's that type of detail that Sebastian was talking about earlier that you cannot mess up. Have to use dotted. Try that again. I keep getting a little bit off, and I apologize for that. That's as close as I'm going to get it for now. And now, before I go on to the next one, I want to shade. So which way am I going to shade? Am I going to shade below or above? And right now, I'm right here. Below or above? Got a lot of people doing it already. Anissa, which way? Below? Yeah, we got a less than symbol. So we're going to shade this whole humongous region down here. Remember to shade lightly with your pencil. Good, you guys are doing a good job, I can tell by your technique. Very good. Shading, well, shading like an artist is not obvious to everybody. So now we're on to the second line. The y-intercept is 1.5, so that's right there. But my slope is now down 1 over 2, or I can go up 1 to the left 2. Either way is the same thing. Up 1 to the left 2. And I need a dotted line again. Now here's the part where it does get a little bit tricky on shading because we have the other line on the grid that's kind of making it hard to see and focus. But now we're looking here and we need to figure out where are we going to shade for this line. Are we going to shade below the line or above it? What did you think? Zabari? What did you think, Catalina? below. So we're going to shade down here, and I'm strategically using my colors again so I can start to see what emerges. Anyone have any questions about what I've done so far before I introduce the new idea of a third line? All right, so this third line is a simple one. You're supposed to know this instantly. So if it was x equals 4, what that means is on the x-axis, you go to the 4, and you put a dot, 1, 2, 3, 4, right there. And then you draw a vertical line that goes through that point. And again, it's a less than symbol, so we need another dotted line. So, right here at the 4, we're going to draw a dotted line straight down. And so now it's getting very complex. And so we have to be extra careful about where we shade. So now for this line here, looking at this symbol, where am I going to, that color didn't show up very well, let's try that one. Where am I going to shade? Am I going to shade to the left or to the right? Because now it's a vertical line, there is no up and down, it's either left or right. What do you think, Hezekiah?
Left.
What do you think, Kamoy?
Left.
So now you have to shade everything to the left of this. I'm using a light color, and I'm hoping we'll be able to see it as it starts to layer. And now, it is a little bit hard to see, but you should be able to see the solution region emerge. If you can't see it just by your shading, then you need to think about it and just kind of analyze which direction you shaded and what makes sense as far as the solution region. So as soon as you're done, if you would put your pencil down and look up here so we can finalize this example together using my version. So let's see what you can figure out just by looking. How many colors are here in this area? Ania, how many colors? Yeah, there's only one color. How many colors are in this area right here, this little triangular area? How many colors do you see layered there? Brian? Yeah, there's 2 colors there. What about over here? This is a little bit hard to see. This area, and it's only up to here, kind of a trapezoid. Right here. How many colors are there? Only 3 people can see it. Zabari, what do you think? Yeah, there's only 1 color. What about right in this triangle that formed in the middle? How many colors are there? Alicia? It's hard to tell because you're a little further away, but this is actually a layer of 2 colors. It's the yellow and this light purple that I used, layered right there in that region. It's a pinkish purplish. What about down here in this little trapezoidal region? How many colors are layered there, Kayla? 2. So where's the region where all 3 got layered? Tristan? Well, it's the one region I haven't pointed to yet, which is this region right here. And so this whole entire region becomes the solution for the system. So now what you need to do is take your pencil and darken in, bless you, that area. Let me see if I can use a highlighter to do it. Let me see if this works. So this red area area is the solution region for the system. So that was a lot of details, a lot of things going on. 3 dotted lines. If you accidentally drew one solid line, the whole thing is wrong. If you shade 2 of the areas right, but then you accidentally shaded this one to the right of this line instead of to the left, the whole thing is wrong. Your y-intercept for one of the equations is off by a little bit, and you put this line a little bit higher up, the whole thing is wrong. So what I'm pointing out to you is not that, oh my God, you're going to be awful at this. What I'm trying to say is, you guys know all the different details to look for. You know what you're supposed to be doing. So just pay attention to those little details. Okay? Any questions? Comments? Concerns? Nope. It's either right or wrong. I know it's tragic to hear, but that's the way it works. Okay? Comments or questions? Number 1. These problems take a bit of time. 6 minutes. Any comments or questions or concerns? Just raise your hand and I will come to you. Okay, so it's not really a question that I can call on volunteers for, so here is the graph. So remember that we're looking only for the solution region, and so even though we use shading to find that region, all that extra shading is not really needed. The publisher used the computer program to generate these graphs, so the publisher didn't have to worry about the extra shading. Now keep in mind that unfortunately if you shade too much as your solution area, then unfortunately it is wrong, so you have to be careful. So if you included, for example, this little triangular area here, that would be wrong. If you included this area over here, that would be wrong. Okay? Comments, questions? Sebastian, we'll start with you.
I don't know what I did, but I rotated my graph somehow, so if I turn my arrow sideways, I have the right graph.
I'll have to come look and see what you did. I'm not sure. The publisher also went by 2s here, so make sure you're aware of that. This is going 2, 4, 6, -2, -4, -6. So give me a thumbs up if you have it exactly correct. Put your thumbs down. So that's 1/3 of the class. Okay, give me a thumbs up if you have the correct lines, but the shading somehow got messed up. Correct lines, but shading got a little messed up. Okay, so that's a few of us. Okay, so comments, questions? Kamoy and then Ania. Well, then, I mean, I'm wondering, is your one line that was slanted is the wrong line.
Yeah.
So you have to check that, make sure you have the correct graph and slope-intercept form. So let's put that down, and I'll get to your question in a second, Sebastian. What will this be in slope-intercept form? Anissa? Excuse me, so y equals negative 3/4 x. Oh, greater than, less than, or equal to, sorry, less than or equal to negative 3/4 x plus 6, you said? Plus 6. So first of all, here's a detail right here, negative slope. That immediately tells you that the line's going to go like that. So that's something that your brain should be picking up on immediately, is the general direction that the line is going to slant. So it sounds like some of you have the line going the wrong way, and that's messing up. So that means you messed up something that you learned from chapter 4, chapter 5. So, I mean, that doesn't make you a bad person, it just means that you have to think about that. You're not messing up something new, you're messing up something that you were supposed to have mastered a long time ago. Okay? So there is a difference there. Okay? Sebastian. And that's why your line goes the other direction. Very good. So that one change, this being positive, would mean that the line is going to go like that, and the whole thing will be different. That one little detail completely changed the graph. Very important to understand. Other comments, questions, concerns? Okay, well, it's the first time you try it on your own, so don't stress about it yet. You'll get better, I promise you. But now we have a little bit more to learn. So far we've learned how to take a system and draw a graph from it. Now we are going to learn how to go in the opposite direction. Now I'm going to give you the graph, and we have to write the system that goes with it. Now, for the example, you do not have to copy the graph. But you need to look up here so that we can work together. So the instructions say, write a system of linear inequalities that defines the shaded region. So this is complicated, and we go step by step. Don't go so fast that you make a foolish mistake. What form have we been using so far today? What form of a linear equation? Brandon? So if we stick with that, and we say, okay, for this line, I want to write an inequality. It's going to be y, there's going to be a symbol here, there's going to be a slope, an x, and then a y-intercept over here. So if I keep that in mind, I can fill in the pieces and just do them one at a time. What's the easiest thing usually to pick out of a graph? What's the easiest thing? Tristan? Slope is easy to pick out. How do you pick it out? The y what?
The y
Oh, okay. I agree with you. I think that the y-intercept is easy to pick out, and since we're doing this line, that's the y-intercept right there. It's positive 2. So we're going to leave ourselves some space because I don't know what symbol's going to go here. And I don't know the slope, and I don't know, I don't know the slope, but I know it's going to be plus 2. That was easy to pick out. But Tristan, you were onto something. What's the other piece of information we need to write the equation? The slope. So now we need the slope from this picture. And to find the slope, we need 2 points on the grid. There's one, and there's one. Draw a slope triangle and find the slope. Rise, run. Now the publisher, I took this from the publisher is going by 2s on the grid. So this is a rise of 2, 4, 6. That's a rise of 6 and then a run of 2. So rise over run, 6 over 2. What is the slope of the dotted line? Eric? Where'd you get 1/4? 6 over 2, rise over run. 3, very good. Caught your own mistake, excellent. So we know that it's going to be 3x plus 2. Does anyone have any questions on how we picked out those pieces of information so far? Any questions so far? So now we need the hard part, which is the symbol that goes right there. The easy part is to figure out whether it's going to be a dotted or solid. I'm sorry, whether it's going to be a bar underneath or not. So is there going to be a bar underneath with this one or not? Hezekiah? No, there's no bar underneath because this is a dotted line. So we know it's either going to be less than or it's going to be greater than. So we have to figure out which one. Which one do you think it is? Based on what you see here. Kayla? Okay, Brian, which one do you think? Think it's greater than? Anita? Yeah, it's going to be greater than because the shading is above the line over here. If I take this line by itself and sketch it over here, the shading is on this side of the line. That's above the line, and so this is a greater than. So we've got one of the inequalities. Does anyone have any questions on how we did that? So now we just need to do it again. This is a skill we learned in chapter 5, writing linear equations or inequalities given a picture. So now the second one, we again know it's going to be y, symbol, slope, and y-intercept. Pick out the pieces of information. You don't need my guidance anymore. You should be able to do it yourself, but we're going to do it together. What's the y-intercept of the solid line, the one I'm using purple with? Kamoy? Do you agree with that? You sure? Yeah, it's -5 right here, because again, the grid is going by 2s, so we know it's going to be -5. Now the slope, I will help you out a little bit because you don't have this in front of you, but we have this point. Well, that's not really a good point. Let's see if we can pick two other ones. We've got this point right here and this point right there. So go over and up. So it's going by 2, so that's 2, 4 to the left. That's -4, and then a rise of 2. Rise over run. What will that slope be? Alyssa? Yeah, -1/2. So we get -1/2 x minus 5. So now we've done the part that we knew how to do from before. Now we need to figure out what symbol goes in between. So what symbol is going to go right here? Start with the easy part. Is it going to have a bar underneath or not? Bar or no bar? Bar or no bar? Kamoy, what do you think? Bar? Yeah. This is a solid line, so there's going to be a bar underneath. So now the question is it going to be less than or equal to, or is it going to be greater than or equal to? We have to figure out which one. Which one do you think? Anissa? Greater than? Hezekiah, what do you think? Yeah, it's a little bit hard to see, but if we sketch the line over here by itself, and the shading's above the line over here, so that would lead you to believe that it's a greater than or equal to. And so we have written the system that matches the graph. Does anyone have any comments or questions on how we did this? Concerns? Tristan? Mm-hmm. Well, it's all based on the shading. So the last step of figuring out which direction we put this in is based on where the shading is. So it's a little bit hard to see because we have two lines. So what I did over here was I took this line and I sketched it by itself over here. You see that this line is supposed to be this one? Now see the shading is up here? It's up. See the shading is up here? Is up greater than or is up less than? Are you sure? Well, it's a 50-50 shot. Up is either greater than or it's less than. Yeah, up is great. The upper is greater. Down is less. Think of the word, up. When you go up, are you going higher or lower? Higher. So just match the words with what you're seeing. It's going to take you some time. It's not going to be super easy and it's not going to be instant. Okay? Good. So let's take a look here. Oops, excuse me. Brandon, any observations you have at this point? Are you sure? You're sure? Okay. Kamoy, you had a comment you wanted to share? I'm sorry? That's it.
They're parallel lines, yes, I'm sure.
How could you be sure?
Because I can,
You can tell. I don't know. I'm not convinced. That's not very.
Okay, I know.
That's not very
I know because you
detail
taught me
oriented.
how parallel lines look, and I know how they look, and I know.
Okay, but they might look like parallel lines and not actually be parallel lines. So what I'm asking is, can you prove it?
Yes.
Catalina and then Jada.
Two things, right? Okay, so they are parallel lines because I checked the slope.
Oh,
And
how'd you do that?
I just did the triangle thing in my mind.
Okay,
And the shading is not a triangle.
okay. The shading is not a triangle. And so that goes back to someone else's point earlier, asking, would the shading area always be a triangle? And I think we've seen enough times already that it's not always a triangle at all. Okay, Jada, what was your observation? They have the same slope. How'd you figure that out? Okay, so if you look, you can actually see from here to here a rise of 2, a run of 3, and then from here to here we have a rise of 2 and a run of 3. So rise over run, we know that the slope is 2 over 3. So we can actually already start writing. So it's going to be 2/3 x, and this one is also going to be 2/3 x. What pieces of information are we missing? Let's start with the top line, the blue one that I wrote. What's missing? Diana, what do you think is missing? I know I put you on the spot a little bit, but that's no big deal. Sure. What do you think is missing from the one I'm writing in blue? Yeah, the y-intercept. Very good. Can we pick that out? Yeah, what is it? Yeah, it's right here. It's -1, so we can easily just put -1. What about the one I'm writing in purple? What's missing from that one? Alicia? Can you pick it out? Yeah, it's right there. It's -4. So So now we just need the correct symbols. So again, that's the somewhat challenging part, figuring out what goes there and what goes there. So let's start with the one I'm writing in blue. Is that going to have a bar or no bar? Tristan, is it going to have a bar? No. Tristan, you were having a moment where you weren't so confident in your ability to figure out. And it's okay if you're still not, but I'd like you to try. So which way do you think this should be? Do you think it should be y is less than? Or do you think it should be y is greater than?
Less than.
Well, you had a 50-50 shot, you got it right. Because the shading is going down here, it's underneath the line, and so that means less than. What about the one I'm writing in purple? Which way do you think that's going to go? Anissa? Yeah, because the shading is going above the line this way, so this is going to be greater than. So again, we have written a system of inequalities that matches the graph we're given. Comments, questions, concerns? All right, so you're going to try one of these on your own. Write a system to match this graph. Pay attention to your details. Any questions, you raise your hand. You got 3 minutes. All right, let's see how we did. Give me one of your inequalities. Give me one of them. Got a lot of confident people. That's nice. We'll start with Jada and then Brandon. Jada, what do you have for your first one? Okay? Brandon, did you have that same one somewhere in your system? You did. Okay, what's your other one?
Y is greater than 2x.
Okay? So, here is the system that I was looking for. Now, Brandon, you said y is greater than 2x plus 1. Okay, just making sure. But that's the kind of missing detail that will get you a question marked wrong, even though you did almost everything, all the hard stuff correctly. So, comments, questions, concerns? Alicia, and then more.
The equations are this, it's not parallel on the they're negative and opposites.
Interesting. Interesting. We'll come back to that in a second. More. Okay, but it's not to the left or to the right. You only do that when it's a vertical line. This is a slanted line, and it is almost vertical, but since it's slanted, above the slant here is greater than, and this is going to be less than. It is a little bit hard to understand, and that's why initially I was hesitant to introduce the shortcut way back when we learned how to do this. It can get confusing. Okay? Now, going back to Alicia, that was a fantastic observation and a fantastic connection she just made. How did you figure out that they're perpendicular? Yeah, the negative reciprocal, or the opposite reciprocal. 2 and negative 1/2. That proves that they're perpendicular. See, before, some people were looking at the parallel lines and they were saying that they're parallel, but they couldn't prove it. They thought that they were parallel. You might think that these are perpendicular, but you have to be able to prove it, and this detail right here proves it. And that was a fantastic thing that she picked up on. Okay? So you guys have done a fantastic job sticking with some very difficult material. I have to modify today's lesson, so we will not be doing classwork portion. So everyone will get a free point for classwork. That's not really a good thing because we need the practice. But your homework. On page 481, you're going to do 10 through 34 even. On page 484, you're going to do the ready to go on, numbers 1 through 3. And then on FL16, you're doing days 1 through 5. We have finished chapter 7. Your chapter 7 test will be on Monday.